Okay, ask the question.
Alright, so Miss, basically what happened is you see how the like this graph we had S and A, but what for example we had tan theta, we'd have to look at it like a diagonal way, like hold that graph some strange looking way.
Okay, hold on. When we finish this, I'll just replace this right here with tan. And yeah, I'll show you what to do when you have tan. Okay. So we just found out within the range, the given range, so between 0 degrees and 360 degrees, the values of theta, when I substitute it into this function, that would give me a value of 0.2. It's not only 11.5, like you would do in regular math or something like that, right? What you would do in regular math, you just say, oh, okay, theta is sine inverse of 0.2. No, that's only one possible value of theta. Within the given range, so between 0 degrees and 360 degrees, theta can be either 11.5 or 168.5. Just to check it out yourself, find sine of 11.5. Can anybody tell me what that answer is? Just put it into a calculator and tell me the answer. To one decimal place.
Miss, sine of what?
Sine of 11.5.
I think that is 0.2. Oh damn, we got the answer.
Now, if you do sine of 168.5, what answer do you get?
0.2.
Also
0.
0.2, yeah.
Yeah, so that proves that if the value of theta is 11.5, or if it's 168.5, I will get 0.2, right? So that's what the quadrants help us to find out. Instead of me going through all possible values theta could be, which includes all real numbers, right? It's just impossible. That is why we have quadrants. It helps us to find the possible values of theta within a given range. So let me just switch this out with tan. So I can show you what to do for tan. Same thing we're doing, right? So say instead of sine theta is equal to 0.2, my equation is tan theta is equal to 0.2. Can anybody tell me what's the value for our acute angle? Oh my. What's the value?
Mrs. Valieva?
The acute angle. So all these green angles there.
Oh, 11.5.
No, this is a different equation. It's no longer sine theta, it's tan theta.
11.
I'm so lost.
3.
11.3. Can you tell me how you got that?
Tan inverse 0.2.
Tan inverse is 0.2. Yes. So that is how we find the acute angle, right? When
Oh,
I say
makes
acute
sense.
angle, I mean the angle from the positive, well, no. I mean the angle between 0 degrees and 90 degrees, and it's always measured from the x-axis, right? So 11.3. All of these angles measured from the x-axis. So remember this horizontal line is my x-axis. All of these green angles, the value is 11.3. So this is 11.3, this is 11.3, 11.3, 11.3. After we find the acute angle, so all these green angles, the next step is to determine which quadrant would the possible values of theta lie in. Is it the first, second, third, or fourth? Remember, it's always 2 out of the 4 quadrants. So how exactly do you determine that? This value here is positive. So then you ask yourself, where is tan positive? First, second, third, fourth. What would you tell me? Where is tan positive?
In T and A?
T and A. Good job. So in order to find my possible values of theta, when I sub it into this function, what possible values of theta would give me 0.2? So I told you we always measuring from the positive x-axis going anti-clockwise. So you go up, you hit right here. Okay, what angle is that? Right here,
11.3 degrees.
11.3. So that means one possible value of theta is 11.3 degrees. If you put it into a calculator, tan of 11.3, you would get approximately 0.2, right? But I also said that the other possible value of theta could be in the third quadrant, would be in the third quadrant. So what do? From the positive x-axis, go all the way around until we meet this line. So to find this angle right here, this angle, hold on, it's giving trouble, right? This angle right here is my next possible value of theta. When I sub it into this function, I'm going to get 0.2. So the question is, how exactly do we find this red angle? Does anybody have any idea how we could find the value of this red angle?
Yes, miss. It would be 191.3 degrees.
191.3 degrees. Anybody agrees with that or disagrees with that? Okay, let me ask. How many people agree with that? That
Yeah,
this,
give me 2 seconds. Let me try to make it.
okay.
I mean, miss, you like, would you like an explanation for like why I got my answer, even though it's
Hold on.
probably wrong?
Oh, why is, don't say that.
All right, miss. All right, miss.
So who told me just now? It was Micaiah. Was it Micaiah who was talking to me?
Yes, miss.
All right. What answer again?
Uh, I'm still trying to look it up, adding up all the values. I don't know if it just take an extra long. Yeah, just trying to add up all the values
Out of all what values?
to find the angle.
But out of what values to find the angle?
Well, that whole angle would be 27. No. Well, I was adding up 11.3, 11.3, 11.3. But I was doing 90, subtract 11.3 to find that space there, and then just adding all of them when I get to it.
All right. But what if I told you the angle? So say this is a straight line. What would this angle be? This red angle.
The,
Not you.
all right, miss. All right, all right.
Okay, what angle would this be? If I told you this is a straight line.
180 degrees.
Okay. So this angle here, from the positive x-axis to the negative x-axis, is 180. But I don't just want this angle, I want this little piece right here. But ain't you already know the value of this small piece here,
Yes, miss.
which is?
11.3.
Okay, so if I want this entire red angle,
Oh,
I would do,
180 plus 11.3.
which is?
191.3.
191.3.
Well
Good job.
done.
Yes, well done. Well done to you too, because you got it. So, all right, these are my two possible values of theta. When I sub it into this function, I would get 0.2. You could try it for yourself. Tan of 191.3. I get, tell me what you get. Anybody tell me what you get?
Miss, what are we doing? I'm so lost. I'll literally zone up for like 2 seconds and I'm dead.
Put put tan of 191.3.
Oh, and by correction, it should give you like 0.2 or something like that.
But I'm asking you, what does it give you?
Oh, sorry, they bad boss.
0.2, miss.
0.2. Let's go, dude.
Positive or negative?
Positive, positive.
Positive.
Yeah.
Mm,
Yes,
Positive.
miss.
Right, anyways, so yes, it works, right? So I'm not telling you nonsense. These are the two possible values within the given range. When I substitute it into this, I will get approximately 0.2. So this is easy thing, man. Right? It's nothing. Oh my gosh, I don't like I sound like I've tight tongue.
Miss, you just said this is easy, miss.
Yeah.
Miss, my head is hurting.
This is real easy. We talking about
You go on, miss. You go on.
all right, let's try another one.
Miss number 4.
Okay.
Oh wait, never mind. You can never mind, miss. You can do number 3.
Yeah, let's do number 3. And then we'll do number 4. So just write down number 3 for me.
The thing is, is it possible like if I could try it first, unless you know what I get?
Okay.
Because I think I have a better understanding of this topic. Yes.
All right. Let me know when you finish. The others could try too.
Oh, miss, question mark. Could you have like a negative angle, even though that doesn't make sense?
What do you mean? The
Like a negative angle.
if you can have a negative angle?
Yeah.
Yes.
For real? So miss, what would it look like?
I'll show you just now.
Okay,
Just
all right.
finish it.
Well, miss, I just got no problems. I'm gonna work on it now and let you know what I get.
Okay. You finished?
No, miss, almost. I'm finding my second value.
Okay.
Okay, miss, I got my answer.
Okay, what answer did you get?
So I 31 degrees and 211 degrees.
Anybody else got that?
No, they shouldn't have because it's like the wrong answer. So yeah, they shouldn't have.
Gosh, why do you think you have the wrong answer? Maybe it's
Basically, you have
correct.
to assume it's wrong so that when it's correct, you'd be so all surprised. And then like, yeah, and the happiness, you know what I'm saying?
Okay, repeat your answers for me.
What did I say? 31 degrees and 211 degrees.
31 and 211. All right.
Are,
Okay.
are they like wrong?
Let's see.
Oh man.
Ah, right. First thing, make sure pay attention to your range. Wait, hold on before I continue. Did anybody else get that answer? Or if you got a different answer, can you tell me what answer you got? Go in once. Go in twice.
Miss, I got the, I think I did it wrong. I think I did something wrong. But I got negative 31 and 211.
Okay, okay. All right. Well, let's see who is correct. All right. The first thing, make sure you pay attention to your range. In this case, the range was between theta is greater than or equal to 0, but less than or equal to 360. Next thing you want to do, find your acute angle alpha. How do we do that? We just do a regular thing, find the tan inverse of this. What's the answer?
That would be I got 31 degrees.
How did you get that?
I use my calculator.
So why didn't you get minus 31? Because in
Oh
my
yeah, yeah. Oh wait, miss. You know why? Because when I put in the negative sign, it came up as domain error or something like that. So I put like it's so lost. You know what I'm saying? Like, I got the correct answer, but I just like the sign because I left out the sign because of like the calculator might explode if I use the sign. You know what I'm saying?
So what's the value of the acute angle? 31
Negative.
or, well, it's 30 point, okay, well, 31.0. What is it?
Yeah.
What is it? 31.0
Yeah.
or negative 31.0?
Negative 31.0, I guess.
You get.
Okay, negative 31.0, miss.
Okay. Anybody else agrees with that?
Yes, miss, I got that. And I just checked it over and the second value I got, well, I just checked it over and I got 149 for my second value.
What the heck?
Okay.
Yeah. So I got negative 31 and then 149.
Okay. All right. Okay. All right. Okay, let's just put the negative sign here, right? So I'm telling you now, this is not correct. This negative 31.0, it's not right. Let me ask you something. What is the range again? Like, what range did they give me?
Is between 0 degrees and 360 degrees.
360 degrees. All right. So, who told me that one of the answers was minus 31?
Me.
Is that within the range?
Oh no. Wait, let's
theta has to be greater than or equal to 0, but minus 31.0, that's less than 0, so that's not in my range.
True.
That makes sense, no?
Mhm. Okay. So, Cartesian plane, y, x, stack. Acute angle. So let me just tell you one thing real quick. When you see a negative angle, all it means is that instead of measuring that angle anti-clockwise, like I told you, you measure it clockwise. So you see how usually I would tell you this angle here is 31, this is 31. I would say this is 31, and this is 31. Actually, you see those two angles that are below the x-axis, those are actually negative. You might be wondering why. So that's how we get a negative angle, right? So you might be wondering why. Why is it negative? Well, I told you positive angles are measured from the positive x-axis going anti-clockwise. So, like this. But if I measure it clockwise, yeah, I would get 31 degrees, but it's negative 31 degrees. Why? Why is it negative 31 degrees? Well, you see that negative sign? It doesn't really have, any significance really. Like in a calculation, you wouldn't put like 180 minus 31. No. The minus sign just tells me instead of measuring it clockwise, I measured that angle anti-clockwise. You understand that? So this negative sign doesn't really have any significance. It just tells me that instead of measuring it clockwise from my positive x-axis, I measured it semi-clockwise now. Instead of measuring it anti-clockwise from my positive x-axis, I measured it clockwise. So let me just draw this out real quick. So yeah, let's just pretend that's straight. I'm gonna just stick with the diagonal thing because, yeah. So an angle that's measured clockwise would be a positive angle. So let's just say this is positive theta. But an angle that is measured, this is anti-clockwise, but an angle that's measured clockwise is a negative angle. So the only thing that negative sign indicates, it just means that instead of measuring my angle anti-clockwise, I measured it clockwise. Do you get that? Yes or no?
Yes, Miss, I get it.
Makayo?
Yes, miss.
So yes, it is possible to get a negative angle, right? I just left it all positive for explanation purposes. The acute angle is the angle from the x-axis. The only thing that the purpose of the negative sign is just to tell me instead of measuring my angle anti-clockwise, I measured it clockwise, right? That's the only purpose of the negative sign. That is why I just left it as positive 31. Because you can see that it's below. Ow. You can see that it's, anyways. Yeah. So what was I doing? Right, tan, negative. Which quadrant? Two of them.
Miss, that would be TNA.
Tan is negative in
Oh, negative. Oh, it's a negative in S and C then.
S and C. That's correct. So from my positive x-axis, I go all the way around and I stop here. Remember, we're taking the angle, this big angle, from the positive x-axis. So what's the value of that angle?
149 degrees.
And how did you get that?
You subtract 31 from 180 degrees and it'll give you 149 degrees.
149. Okay. If I drew another one of these yellow things, and I said the other possible quadrant is in the fourth quadrant, so I go all the way around until I stop here at this line. What's this big value?
329 degrees.
Where did you get that?
I subtracted 31 degrees from a revolution, which is 360 degrees, and that gives me 329 degrees because I'm just so incredibly smart.
Oh gosh, these are kicks. Anyways, so wait. Right. Anyway, those are my two possible values of theta. All right, 149 and 329. I mean, if you put into a calculator negative 31, I mean, technically, you're not correct. Like if this was my range and I just left it as infinity, well, not range, well, my domain, I just left my domain as all real numbers. So going down to negative infinity and up to positive infinity, negative 31 would be valid. Why? Because if I say tan of negative 31, I will in fact get negative 0.6. However, they gave me this range. So what does that mean? My value of theta must stay within the range. Negative 31, it's less than 0. So therefore, it is not in my range. So it wouldn't be accepted in this case. But I mean, technically, you're not wrong. Because negative 31, if theta was negative 31, it would in fact give me negative 0.6. So you good with that?
Miss, can we get like another one to do? Because like like I want to get better. And also Miss, I had a question. So the answer I gave 31 and 211, that would literally just be for tan theta equals 0.6, like without a negative.
Hold on. 211, 1k plus 31. Oh, yeah. Why am I even practicing that? Yes.
No way you did that so fast.
What?
All right, Miss, don't worry, you're cheating. We get you.
I'm not cheating. This thing is really easy, you know.
That's what you think, Miss.
Yes, because it is easy.
Yikes. Well, yeah, I no words.
Okay. Hold on. Give me a second. I need to plug this in because it's not working out for me. Give me a second. I didn't show you before because, sorry, because I didn't want you to rely on this too much. I wanted you to understand why that is the case. So my quadrant stack. To find the angle in the first quadrant, it's just alpha. The angle in the second quadrant, if it lies in the second quadrant, what you're going to do, if your range is in degrees, you say 180 minus alpha. That is how you get the angle. You know, instead of drawing that, you know, that yellow arrow that I was drawing, this is a simple thing you could do. if you know that the angle is supposed to be in the second quadrant, or you say 180 minus whatever your acute angle is. The tan is 180 plus alpha for this last quadrant is 360 minus alpha. So the same thing you were doing, but instead of drawing those arrows, how? You can just use these in red. That's when you're given your angle in degrees. If you're given the angle in radians, then instead of 180 minus alpha, you say pi radians minus alpha. So we know 180 degrees and pi radians, they're equivalent. That's why I can say this. Pi plus alpha, 360 degrees is the same as 2 pi radians. So I can say 2 pi radians minus alpha. All right, you try now.
So Miss, basically, we only get the shortcuts after we did the learned it by brute force.
Yes, exactly. You get
Mrs.
it.
Mrs. Headache still raging on
Don't worry, just take some Panadol, paracetamol. You'll be good to go by
yes,
tomorrow.
yes, yes. Yes, I'll take some marijuana later.
All right. Let me give you, I think you need just 1 minute. And then
1 minute? Miss, what about, okay, Miss, let's negotiate this. How about until the end of the class?
I
Deal?
was joking.
Oh, okay, thank God. So that we go to the end of the class?
Oh,
Oh man, that's not cool.
I think 2 minutes. You have like, I don't know, 60 seconds now. But anyway.
Miss, like I'm actually drawing out the graphs now. That's the sad part.
Well,
I miss I'm just like you, but like with the mouse on life support, like you know what I'm saying? Like the graph kind of grows straight.